All right, last section before your final and your final review, okay? Lesson 46. 46 is related rates, okay? So what is a related rate problem? And then working through one, okay? So a related rate problem is a problem that presents a situation where you have one or more related quantities that are changing, okay? And it asks for the rate that one is changing to make it a related rate, right? So two quantities that are related to each other that are changing and asking for the rate that the one is changing, okay? So the first step here is to write an equation that relates the variable quantities, so called the relating equation, right? So how do they relate, right? You can't solve anything if you don't know how they relate to each other. Differentiating then helps us to take the equation and create a rate of change in it, right? Because the derivative is a slope. Slope is a rate of change. So differentiating that relating equation gives you a new equation to tell you how the rates change related to each other. Okay, so dy, dx, dx, dt, things like that. Okay, so once you do that, then you can take specific information from the problem and substitute it into the differentiated equation. So seems like a lot of problems relate back to differentiating, and if you so desire, or if you continue on in math when you get to college, you can take an entire course, and if you major in the math and science field, you probably have to, just called differential equations, an entire semester long, maybe even 2 semesters if they have differential equations too, okay? So because it's a rate of change, a lot of problems can come back to this differentiating idea, okay? So a general principle that applies for these types of problems is that the sum of the number of rates given and sought should equal the number of variables in the relating equation before you differentiate it. Okay? So the number of unknowns relates to the number of parts of your equation. Okay? So this is kind of a classic example of a related rate problem. Okay? So I don't want to necessarily write the whole thing out because you guys have it right here. Right? If you look to the notes that I posted for you, okay? This is what we're looking at. So what it says is that you have a 10-meter long ladder, leans against a vertical wall. Okay, so I would stop right there and kind of draw out what you're looking at, right? Because a lot of the times you need to see it before you can solve. So here's your vertical wall, okay? And here is your ladder. It tells you that the ladder itself is 10 meters long, okay? And it's leaning up against a vertical wall. Great. The base of the ladder, okay, is pulled away from the wall at a rate of 1 meter per second. So it's like it started, right? So kind of like started against the wall, right? Then I'm going to start slowly moving it away from the wall, right? So this distance away from the wall is changing, as well as how far the top of the ladder is from the floor, okay? So we know we are creating a right triangle here because the wall and the floor are forming a right angle. So we're going to label this as a 90-degree angle. The distance away from the wall is going to be x, because the base away from the wall, because it's horizontal, and our horizontal axis is always x. That makes it easy. And then the height of the wall is going to be y, right? Again, same reasoning because it's vertical and the vertical axis is always y. Okay, so this is changing at a rate of 1 meter per second. What we want to then find is how fast is the top of our ladder sliding down the wall. So what is the rate of change here when the base of the ladder is 4 meters away from the wall? So when this distance is 4, what was that rate of change in the y direction? Okay, so the very first thing you have to do, right, is to write an equation that relates the two variable quantities. So variable quantities in this sense are the two variables that are changing. So the height on that the top of the ladder is on the away from the floor, and how far away the base of the ladder is from the wall. Those are two variables that are changing. Well, the nice thing that we have here is we have a right triangle, right? So to relate these two variables that are changing, we can use the Pythagorean theorem. It tells us that leg squared plus leg squared equals a hypotenuse squared. So x squared plus y squared equals 10 squared. We have related x and y to each other. We can simplify this because we know what 10 squared is. So x squared plus y squared equals 100, right? We just use the Pythagorean theorem. Okay, then we're told once you have your relating equation, we're going to differentiate this, okay? So differentiate. So derivative of 2x, right? That's 2x dx, because we're differentiating, plus 2y dy equals 0, because we're differentiating with respect to x, with respect to y, because this is where our change is going to come in, okay? Then we want to differentiate with respect to time, so we can go back and say, okay, we're going to divide everything by the change in time. Zero over the change in time is just 0. We don't really need to write this, okay? So we had 2x dx dt plus 2y dy dt equals 0, okay? So we're looking to solve for the rate that the height is changing. So basically dy dt, okay? When x is a given distance. So we're going to start by getting that by itself, okay? So we're going to subtract 2x dx dt because we're going to keep this positive because that's what we want. So we get 2y dy dt equals negative 2x dx dt. Okay? You want dy dt by itself. So, because that's the rate of change, right? So you want the rate of change by itself. So we're going to divide everything by 2y. And we get that the change in y with respect to time is equal to negative x over y dx dt, because the 2's cancel. Okay? Then we're going to have to plug in numbers, right? Because we need dy dt. So it's saying now go back to the word problem, right? Because you've written your equations, and plug in the information you have from here into that equation. Okay? So then we're told that we want to find out when x equals 4, and that the rate of change of y, or of x, it's sliding away from the wall at a rate of 1 meter per second. Okay? So again, this is what we had, and then when we differentiated, we got that dy dt was equal to negative x over y times dx dt. The change in x with respect to time. Okay, so just plugging in what we know, right? So we know that dy dt is going to equal negative, it says when x is 4, so negative 4 over the change in x with respect to time was the 1 meter per second. Then we just need to find y. But that's where we come back to our original problem, because it says that x is 4 when x is 4. So when it's 4 meters away from the wall, how far is the top down from the floor, right? So we're going to solve for y. So y equals the square root of 100 minus 16. 100 minus 16 is 84, which is 4 times 21. So that's 2 times the square root of 21. Right? We're looking for exact answers. So y is 2 times the square root of 21. It's not negative even though we took the square root because it's a height. So then we're going to let that go in for our y value. And then simplify. So negative 4 divided by 2 is negative 2 over the square root of 21 times 1. But we know we can't leave a radical in the denominator, so we're going to multiply by the square root of 21. So dy dt equals negative 2 times the square root of 21 over 21 meters per second would be the rate that the change in y, so the rate that it's sliding down the wall. Makes sense that it's a negative because the height is going to be getting smaller as the base of the ladder moves away from the wall itself. Okay, so related rates problems generally have more unknowns or more parts to it. So it's going to start out as being something you've done before, right? You know how to write the Pythagorean theorem. You know how to set up ratios for heights. You know how to find volumes and areas and perimeters, okay? So you have to first write an equation, generally an algebraic equation, that relates the variables that you have. So you're going to have two different things changing, right? It could be the ladder moving away from the wall. It could be you have a cone and you're filling it up with water, right? How is the volume changing if the height of the cone is changing at a given rate, okay? So you should have two values that relate to each other plus at least two rates of change, because when you take the derivative, you take it for each part. So you're going to take it with respect to x, with respect to y, and then you get two rates of change, how your two variables are changing with respect to time. Okay, so write those first, differentiate, and then plug in your numbers.